Okay, so when you look up at the night sky, you see all those stars, right? All those galaxies. It's breathtaking. But what if I told you all that stuff, all that light, is basically just the glitter on top of a massive, invisible skeleton that holds the entire universe together? Yeah, today we're diving into one of the biggest mysteries out there: dark matter, the universe's hidden architecture.
This quote it nails it, doesn't it? For so long, we built our entire understanding of the cosmos on what we could literally see. But it turns out, all that visible stuff is, well, a ghostly afterthought. It's just a tiny piece of the real picture, and it's all being pushed around by something we can't see at all.
And this chart, this really puts our cosmic ignorance on full display. Just look at this thing. Everything we've ever seen, everything we've ever touched, the stars, the planets, you, me, it's all packed into that tiny 5% sliver. The other 95%, it's it's a complete mystery. Now for today, we're going to zero in on that big 27% chunk, dark matter. Okay, so if we can't see it, how in the world do we know it's even there? Well, it all starts with what looks like a cosmic crime scene. See, entire galaxies are acting weird. They're breaking the laws of physics as we know them, and all the evidence points to some kind of invisible accomplice, a ghost that leaves behind only one clue. It's gravity. All right, here's the core of the problem. Astronomers looked at galaxies and they saw them spinning, but they're spinning way, way too fast. Think of it like a merry-go-round spinning out of control. Based on all the stuff we can see, the stars, the gas, the stars on the outer edges should just be flying off into space. But they're not. They're holding on. And the only way that's possible is if there's a ton of extra invisible mass in there, providing the extra gravity to hold it all together, some kind of cosmic glue. And this wasn't some eureka moment. Not at all. This was a classic detective story, a real slow burn that took decades to unfold. It was all thanks to a few incredibly sharp astronomers who trusted the data, even when what it was telling them sounded, well, completely impossible. So let's check out how they started cracking the case. So the first big clue comes way back in the 1930s. An astronomer named Fritz Zwicky, he's looking at this cluster of galaxies, and he sees the same thing. They're moving way too fast. He even coins the term Dunkel Materie, that's German for dark matter. But get this, his idea was so out there, so bonkers to everyone else, that it was basically ignored for decades. It took until the 1970s for another brilliant astronomer, Vera Rubin, to come along with the proof that was just too compelling to ignore. And this is the bombshell she dropped. On the left, that's what physics says should happen. Just like in our solar system, the further out you go, the slower things should move. Simple enough. But on the right, that's what she actually saw. The stars on the very edge of the galaxy were moving just as fast as the ones near the center. It makes no sense. This flat rotation curve, this was the smoking gun. There was no other way to explain it. Every single galaxy had to be sitting inside a giant invisible halo of dark matter. So, Vera Rubin's work was a game changer. It basically proved that dark matter is running the show in individual galaxies. But the story doesn't stop there. Oh no. The investigation was about to go cosmic. The evidence wasn't just lurking in galaxies. It was stamped all over the entire universe, right back to the very beginning. I mean, the evidence is just everywhere you look. You take the baby picture of the universe, the cosmic microwave background, the patterns in that light only make sense if you have dark matter in the recipe. Then you try to build a universe in a computer. Guess what? Our simulations totally fail to make anything that looks like our cosmos unless you add in dark matter. It's like it's the invisible scaffolding that the whole cosmic web of galaxies had to be built on. So it's kind of like a recipe for building a universe. Step 1, dark matter gets a head start. Because it doesn't care about light or radiation, it starts clumping together way earlier than normal matter ever could. It forms this huge invisible skeleton. Step 2, gravity does its thing. All the regular gas and dust gets pulled into these big dark matter pockets. And then step 3, a star is born. The regular matter ignites, forming stars and galaxies, basically just lighting up the invisible skeleton that was already there. Okay, so at this point, the evidence is just overwhelming. Dark matter is real, it's out there. But that just opens up the real million-dollar question: what in the world is this stuff? And that question has launched one of the biggest, most expensive manhunts in scientific history. Physicists have a lineup of suspects, and let me tell you, they are pretty weird. For a long time, the number one suspect has been something called a WIMP. That stands for Weakly Interacting Massive Particle. And honestly, it's the perfect criminal profile. Massive? Check. That's where the gravity comes from. Weakly interacting? Check. That means it just ghosts right through normal matter without a trace. It doesn't interact with light, which is why it's dark. It's a perfect fit. But, WIMPs aren't the only game in town. There are other contenders, like the Axion, which is on the complete opposite end of the scale. Super, super lightweight. For a long time, the WIMP was the favorite, but the Axion is a really plausible alternative. The bottom line, though, is that whatever dark matter turns out to be, it's almost certainly a brand new type of particle that's completely outside our current understanding of physics. So, let's think about this. How do you possibly catch a particle whose main characteristic is that it's invisible and passes through everything? It's like trying to catch a ghost with a butterfly net. It takes a massive global effort, and scientists are trying to corner it with 3 completely different strategies.
All right, strategy number 1, go hunting. Scientists go deep, deep underground, like in old gold mines, to shield their experiments from all the other cosmic junk flying around. They build these ridiculously sensitive detectors, and then they just wait. Seriously, they're just sitting there, hoping that one of the billions of dark matter particles that are passing through you and me and the entire planet right now will just by pure chance smack into one of the atoms in their detector and leave a little ping. Strategy number 2 is the opposite. Instead of digging down, we look up. This is called indirect detection. The theory goes that every once in a while, 2 dark matter particles might collide out in space and annihilate each other. If that happens, it should produce a burst of something we can see, like gamma rays. So we use our space telescopes to scan the skies, looking for the smoke from a dark matter collision. And finally, strategy number 3, the most brute force approach of all. If you can't find it, make it yourself. This is what they do at places like the Large Hadron Collider. They take protons, accelerate them to almost the speed of light, and just smash them together. The hope is that in that insane burst of energy, they might actually create new dark matter particles right there in the lab. And even if they fly away unseen, they'll leave a signature that the detectors can pick up. So we have these 3 amazing strategies, right? We're digging deep underground, we're scanning the heavens, we're smashing particles with incredible force. Decades of work, billions of dollars, some of the smartest people on the planet, and the total number of dark matter particles we have unambiguously detected is 0. A big, fat nothing. The ghost is still a ghost. And as you can imagine, this silence is starting to make physicists really nervous. I mean, really uneasy. It's forcing everyone to ask a super tough question. Are we just not looking in the right place or with sensitive enough tools? Or could our whole theory be wrong? Have we been chasing the wrong suspect all this time? This has actually opened the door for some more radical ideas, like a theory called MOND. MOND basically says, hey, what if there's no dark matter particle at all? What if our laws of gravity are just wrong? The idea is that gravity just works differently over huge galactic distances. It's a wild thought, but the problem is, MOND has a really hard time explaining other things we see, like that baby picture of the universe. So for now, the particle idea is still the frontrunner, even if it's a frustratingly invisible one. Which really brings us full circle, doesn't it? The whole mystery of dark matter is, well, it's humbling. It's a huge cosmic reminder that everything we can see, everything our best instruments are built to detect, is just tuned into a tiny, tiny fraction of what's really out there. The universe is just so much weirder and so much bigger than we can even begin to comprehend. And maybe that's the most important takeaway. We now know that something like 85% of all the stuff in the universe has been hiding from us this whole time. The cosmos is literally built on a foundation of darkness. And it just makes you wonder, doesn't it? What else are we not seeing? What other fundamental parts of reality are staring us right in the face, completely invisible?